Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of what to look for in the night sky. We're talking about the week of June 10th. This time around, we're getting into a nice, real summertime sky. It's a week, we always kind of pay attention to what the moon's doing, because when there's too much moonlight, it messes everything up, right? It washes out all of the faint objects that we want to see in the night sky. But in addition to that, a bright full moon isn't very good for observing in and of itself. So what you like to do is get out and look at the moon. You're much better off looking at the moon when it's somewhere near, let's say between a third and two-thirds full, or a third and half full, where you can see the long shadows around the sunrise-sunset line. So this week, the moon goes from about 25% full, about a quarter full, to about three-quarters full over the course of the week. So not terrible. By the end of the week, it's starting to become pretty bright and pretty hard to watch. It starts to wash things out. But even by the end of the week, it still sets at about 2 in the morning. So if you're willing to get out, it sets a little bit later each night. So if you're willing to get out a little bit later to look at stuff, or get up early in the morning to look at stuff, the moon will be gone and won't affect your observing that much. Now, it will make as it does this, as it moves through the week, it's about 30% full on the evening of the 11th when it passes Regulus. And then on the evening of the 16th, into the morning of the 17th, it'll be over near Spica in Leo and Virgo here. So the moon does have a couple of nice close pairings with two really bright stars. So that's something to check out if you want to enjoy the moon passing through the stars this week. I thought it'd be a good time for us every time this year, probably twice a year. We talk about the center of the galaxy and globular star clusters, and looking toward the center of the galaxy. And this is a good time to do that. One of the brightest, easiest to recognize asterisms, patterns of stars on the sky, in the summer sky, is Scorpius. And Scorpius has this orange star Antares right here, and then 3 stars that mark the head. Remember, the magnitude system counts backward. Anything brighter than about third magnitude is a pretty bright star. It's going to pop out for you. And Antares is a 1.1 magnitude star, so it's a very bright star. Every step in magnitude is as a factor of 2.5. So this is 5 or 10 times brighter than the stars that we're saying, yeah, these really pop out for you. And to the west of Antares is these 3 stars that mark the head of Scorpius. That's just a very recognizable pattern. You've got the Beta, Delta, and Pi star in Scorpius, and they're all sort of range between 2.3 and 2.9 magnitude. So again, anything brighter than about third magnitude is pretty bright, so these things really pop out. The rest of Scorpius is pretty bright too, with the sweep of the scorpion's tail that comes down this direction, but we're not going to pay a lot of attention to those stars this time around. We can look at those another time. But we want to identify the other stars in the region, and one of the ways we're going to do that is we're going to think, okay, let's look and see what we can do here to say the sweep of the head of Scorpion, those 3 stars, the brightest stars in the head of Scorpius, are about 6 degrees separates them, so a little over half a fist width at arm's length or something like that. And so that gives us a sense of scale of what we're talking about here. Something like 16 degrees. I had it written on the board at one point and apparently have erased it. But if you step north, something like 16 or 17 degrees, so 2.5 times. Basically go 2.5 times this separation up here. You come to another star that's about as bright as those 3 stars in the head of Scorpius, right? So that's a good thing to be able to say, okay, this star is about the same brightness. There aren't many stars that are that bright that you're going to pass along the way. And that's the Zeta star in Ophiuchus. Ophiuchus is the serpent handler, sits above Scorpius. So you got Scorpius and you got Sagittarius, and Ophiuchus is this big loop of stars. And we'll look at more in the coming weeks. We'll look at more of these stars in Ophiuchus. But there's the Zeta star, and see if you can identify that as Zeta star. And so that Zeta star then, we can go either direction about 9 degrees, about 1.5 times the spread between the 3 stars in the head of Scorpius, and go either direction, northwest or southeast, and you get to the Delta star. Sometimes Delta has an L in it. You get to the Delta star and the Eta star in Ophiuchus, and they're also in this same range. So you got 3 stars up here spanning almost 19 degrees. So a big stretch, 3 times the stretch of this. But you got 3 stars up here that have about the same brightness as the 3 stars in the head of Scorpius along here that you can see. And so you can find those stars, and then you can drop down from the Eta star and you get down to Theta in Ophiuchus down this direction. And it's a little bit fainter at 3.3, but that's still pretty bright. Okay, 3rd magnitude again. We're talking, that's what we're calling really good bright stars today. Maybe till next time we make 4th magnitude that and 2nd magnitude. I don't know, but they're pretty easily visible stars. This one you'll notice is a little bit fainter, and that's about the same distance. So you go 9 degrees, 9.5 degrees up, 9.5 degrees down, 9.5 degrees, drop straight to the south below Eta, and you get to Theta. This is all great. So this allows us to find the stars of Ophiuchus. And because the center of the galaxy is right here, okay? The center of our Milky Way galaxy is right that direction. Sagittarius sits behind Scorpius, and on the border between Sagittarius and Scorpius is the center of the Milky Way galaxy. And Theta's great. Okay, one of the things we can do this week is if we can find this Theta star, just kind of drift this direction from Theta, and just use your naked eye or a pair of binoculars and look at all of the glowing star clouds. If you've got a dark sky, if you're blessed with a good dark sky, you can see the glow of the center of the Milky Way. The Milky Way looks like this, right? We draw this all the time on there. And we're here looking toward this central bulge right here, right now. And you can see these star clouds. And you see dark dust and molecular clouds of gas that are obscuring the background. So you'll see dark regions, bright glow of the Milky Way, and dark regions in there where you've got the foreground material that's obscuring the light. So check that out. Take a picture with your phone. A lot of people went out and took pictures with their phone of the aurora and got good pictures of the aurora. You might be able to do something similar as you drift sort of south and west of Theta, Ophiuchus. You can start right on Theta and just start taking some pictures in this region and see what it looks like to you. See if you can see the glow of those dark clouds and some of the dark obscuring regions in front of there. So this is all good, but the center of the Milky Way galaxy is dotted with globular star clusters. In fact, if you count up those that are listed in this book, this star clusters by Archinal and Hines, I counted them up once, and their list in there anyway of the globular star clusters that they list, half of them exist in these 3 constellations. 88 constellations on the sky, and so if they were evenly distributed across the constellations, you would expect about 3/88, 4% of the globular star clusters to appear in these 3 constellations of Scorpius, Sagittarius, and Ophiuchus, and yet it's over half that's listed in that book anyway. And so a lot of globular star clusters. You start with Antares here, and M4 is right next to Antares. See if you can find it with a pair of binoculars or a small telescope. Draw the top star in the head that we were using right there. Draw a line up towards Beta, and just over halfway there, you're going to run across M80. M4 is big and sprawling, a huge globular star cluster. M80 is tight and bright. And so see if you can see the difference between those. You've got just back this direction, some 7 degrees. Remember, that's 6.5 degrees, so you go about the same direction, the same distance back over here. You've got M19, and then drop 4 degrees down here to M62, the globular cluster. So you can find these globular clusters. If you move up here to Eta star, you just drop about 3.5 degrees, about half of the separation of the head stars of Scorpius. Down from the Eta star in Ophiuchus, you've got M9, a beautiful globular cluster, and Zeta, the Zeta star, we've got M107, is just about 2 or 3 degrees down below right there. It's about 2 or 3 degrees, 2.5 degrees below the Zeta star is M107 right in that region. So you've got another globular cluster you can find. See how many you can find. See what you can see with binoculars. See what you can find with a small telescope. Just play around in this region. Now, if we get to Theta down here, and we want to drop about 8 degrees south of Theta, you come to M6. M6 is an open star clusters. Open star clusters dot the disk of our galaxy, so we see them looking straight through the disk down toward the center of the galaxy here. M6 is a big, bright, open star cluster, and another 3.5 degrees below that, you'll get M7. And this is another big, bright, open star cluster. These, under good dark skies, if you got a good southern horizon, you can see these without any optical aid. You see these glowing patches on the horizon. Binoculars will pull them out, or a small telescope will start to show them as glittering stars right here. All of this region, we start with Antares, we look at the head of Scorpius and use it to find all this. All of this is well up in the sky as it gets good and dark now. And we wait for the moon to go away just a little bit. By midnight, this region of the sky is transiting. It's crossing that meridian line that passes north and south. So it's about as well placed as it's ever going to get this time of year. And so this is a really good time to get out and view this stuff. If you're out around 11 o'clock, the moon, early in the week, the moon will have gone away and there won't be much moonlight. If you wait until 1 o'clock, then later in the week, the moon will have gone away. And so sometime between 11 and 1 this week, this region of sky is great. See if you can find these stars and walk your way around from Scorpius to Ophiuchus and see if you can find all of these globular star clusters and a couple of beautiful open star clusters in there. That's what we got for you this week. As always, thanks for watching, everybody, and I hope you have a great week.